Have you ever asked yourself, how do I live? How do I carry out processes? How much of the energy that I take in is actually converted into biomass? Well, it's okay, nobody has. But we'll explain it anyway.
Hello, I'm Adam.
I'm Gayatri.
And I'm Dorothy.
And we're going to be teaching you about the Energy Dynamics Lab.
This Energy Dynamics Lab will explain all that you need to know about energy, energy transfer, energy loss, and so on. The sun provides Earth with light energy. Only a tiny fraction of light energy gets absorbed by our atmosphere.
I'm the sun.
But light energy obviously cannot be used by animals. Where does the light energy go?
Good question. Plants take in light energy and convert it into chemical energy. They are called primary producers since they produce chemical energy and are the first to take in energy that comes to our Earth, our biosphere.
Each animal that eats a plant is considered a consumer. Herbivores are primary consumers since they eat the producers, and then whatever animals eat the herbivore is a secondary consumer.
Followed by a tertiary consumer, then a quaternary consumer, and so on. Each living organism, though, goes through metabolic processes to carry out life. Plants need and lose energy for photosynthesis, growth, and tropisms. Animals lose energy for cellular respiration, excretion, and heat loss. So not all of the energy that they take in will be used as extra biomass that they need to survive.
Subsequently, about 10% will be converted into biomass, although you might find in this lab that it's not necessarily 10%.
Energy can be demonstrated by a snowman, because each level only gets a certain percentage of the energy that each level below it provides.
This here, the bottom layer is the primary producers. It's the biggest by far. And then here we have our primary consumers, which would be like herbivores, like a gazelle. And then up here we have our secondary consumers, which would be like something that would eat a gazelle, like a hyena. But there's more levels, but we're limited.
As we said, not all the energy that is consumed by living organisms is actually used. Both plants and animals go through the processes that cause energy to be used up or lost. The total energy that an organism creates or consumes is gross primary productivity. Through processes such as growth and metabolism, energy is lost. The energy that remains is the net primary productivity. Pretend the darts are incoming energy. Some of it will reach the center ring, but others will land on the surrounding area. So only the energy that comes into the center will end up being the leftover energy that an organism has to use. The rest is lost or used up.
So to start, we have the pre-lab, and we will be using colored water to represent the amount of energy in each trophic level. The largest beaker represents the sun, which has the most energy. Primary producers then absorb the light energy and convert it to chemical energy by photosynthesis.
The primary consumers then eat them and acquire 10% of the primary producer's energy. Secondary consumers consume 10% of the energy from them, and so on. This continues with the tertiary.
Are there any more levels?
No, because after the tertiary consumer, the trophic levels will become unstable due to an insufficient amount of energy.
Now, the gist of this lab is testing the 10% rule.
How do we do that?
First, we're going to grow and dry 40 Wisconsin fast plants. We'll dry them so that we're only measuring their biomass and not the water that's in them.
Because water weighs something.
Then we'll weigh them to determine that biomass, and therefore how much energy they're storing. Each gram contains 4.35... Oh my god. Each gram contains Each gram contains 4.35 kilocalories of energy. So multiply this number by the number grams, and then this will represent the primary productivity.
Now we'll be using Brussels sprouts producers and the cabbage butterfly larvae as primary consumers, as well as secondary producers.
Feed those larvae the Brussels sprouts for 3 to 5 days and obtain the larvae's wet mass at the end. Place the Brussels sprouts and the frass in the oven to get the dry mass.
Using that, we can determine the percent biomass, which should be around 10% theoretically. Each gram contains 4.35 kilocal of energy. So,
oh my goodness.
Kilocalories! Say kilocalories.
Guys, I made the...
Well,
not even doing
trying to make
big
a snowman to represent the energy transfer pyramid, because each layer gets smaller on top. That's how much energy is absorbed by each organism.
Maybe this could be the middle.
Hey Adam, hey. Have you ever asked yourself, how do I live? How do I carry out processes? How much of the energy that I have taken actually is converted into biomass? Well, it's okay, nobody has. But we'll explain it anyway. This energy dynamic...
So this lab, the energy dynamics lab.
Ew, I don't want to sit next to him!
Yeah. Hello, I'm Adam.
I'm Samantha.
Ready?
Adam, ready?